The following alteration was performed on an aircraft. A Model B engine weighing 220 pounds was replaced by a Model D engine weighing 235 pounds at negative 53 inch station. The aircraft weight and balance records show the previous empty weight to be 1,002 pounds and an empty weight CG of 15.89 inches. What is the new empty weight center of gravity? So we have our aircraft. It already has an empty weight and an empty weight center of gravity, but modifications were made so we can calculate the new empty weight center of gravity instead of having to reweigh the entire aircraft and redo the entire empty weight CG calculation. So let's go back to our equation. We have wham. We're going to use that. We do know that we have an empty weight of 1,002 pounds, and we know that that is at a distance of 15.89 inches away from the datum. So that's right over here, 15.89 inches. That's where our old center of gravity was. It will slightly change because we've changed the weight distribution of the aircraft. So we can just go ahead and get our moment. So we're going to multiply these two together, the weight times the arm, to get our moment. And then here we go, 7, 8. All right, then we know that what we've done is we've removed 220 pounds of weight. But what we did was added in 235 pounds. So after both of those, what we've really done is just added 15 pounds of weight to this aircraft. So we're going to go ahead and go with 15 pounds of weight is added. So with added, that's going to be a plus, all right? We know that anything forward of the datum is going to be a negative sign. Anything aft of the datum is going to be a positive sign. So in this case, this is forward of the datum, and it's forward of the datum, it says negative 53 inch station, or fuselage station, negative 53. So we'd have 15 times negative 53, which is equal negative 795 pounds. Again, remember, this is just our kind of like our torque equation. Moment equals weight times the arm. So we want to have our arm. That's what we're trying to find. So we're not going to use the middle column. So we'll go ahead and add this new weight. So our new empty weight is heavier because we put a heavier engine in it. And our new moment is going to be changed as well. All right, so perfect. So we have this. We're just going to use the equation wham. That's where we were at. Weight is 1017 times the arm equals 126.78. So we're going to divide this side by 1017. Anything divided by itself is 1, and we're going to divide this side by 1017. So we know that our arm now is equal to 14.87 inches from the datum. So this actually moved forward slightly by around an inch.